Hi everyone, Mr. Listing again. Good to see you. We are off to Special Right Triangles investigation number 2, and this is going to be very similar to the previous one. Different values, a different scenario, a different pattern, but the process is going to be the same. That said, as a refresher, these are the directions. Excuse me, I'm gonna move my head. Ooh, kind of hurts my neck a little bit. These are the directions. You're going to again find the table momentarily and try to fill in the missing values using Pythagorean theorem, and of course using simplest radical form. And if you need a refresher yet again, as far as on Pythagorean theorem, there you go. Again, it's leg squared plus leg squared equals hypotenuse squared, not hippopotamus squared. All right, let's get at it. So there's your table. And just like before, you're going to hear a sound. I'm about to change the slide. So if that's too fast for you, please just pause it and then play whenever you are ready. So same sound as before. If you remember, that will be this sound. So if you're hearing that, no, I'm about to change the slide. So we're going to do the first three and then reassess. I'm actually going to walk you through the first one this time and then hopefully have you try B and C on your own. Of course, we'll check on your answers. So let's get moving. First one, you got leg squared plus leg squared equals the unknown, so the hypotenuse squared. And hopefully, again, you're getting used to this whole idea of a number and a root being squared. Again, the outside number gets squared, and a squared square root being squared. Again, they offset, and the number just pops out. This plays out to get you a 196. Now the idea is there a perfect square that goes into it? And lo and behold, 196 is a perfect square. I mean, I've known that one naturally, and that's okay. That's the beauty of a calculator and or brain power. But turned out to be a nice, neat 14. So see what you can do with the next two. Hopefully you got 11 root 3 for the second one and 5 for the third one. So we're going to do the next three in a second, but again, the idea is we are looking for a pattern here. And I think just scanning those first three, you might be seeing something. Probably not quite as obvious as the previous pattern that we looked at, but I'm thinking you're seeing something. All right, let's try that same process for D, E, and F. Again, doing Pythagorean theorem in simplest radical form. And I'm going to walk you through D and give you a chance to try E and F on your own. All right, let's look at D's work a little bit. So there's my setup. Again, leg squared plus the unknown leg squared equals hypotenuse squared. Excuse me. Apparently I wrote that line twice just for emphasis. Who knows why? Yes, same deal. Outside number gets squared. Again, square root being squared, number pops out. That happens here as well. I'm thinking you can follow the arithmetic there. We're definitely not done, but I'm thinking as far as multiplying, subtracting, you can process that. Now, as far as perfect squares in 324, that's not a natural thing. I doubt anyone knows that naturally. So first, see if it is a perfect square. And then if it's not, try to find a perfect square that divides into it evenly. So in doing that, that's how it plays out. Yep, lo and behold, 324 is a perfect square. And again, no one expects you to memorize that, but just type it in first. If it gets you a decimal, then you got some work to do. Gets you a nice, neat whole number that turns out, hey, that is indeed a perfect square. All right, two more to try. Let's see what you can do. All right, so for E, hopefully you got 9 root 2. And the last one, F, hopefully you calculated a 2 root 2. So, just as before, the idea is, are you seeing a pattern in this table? So as we said before, I think the first three you might be seeing something. The question is do the latter three still have that same pattern working, or is it still applying to those as well? Play a little more, see if you can see anything, and then we'll chat about it in about 5 seconds. All right, so a little trickier to see, but hopefully you can see that the leg was whatever it was. The second leg was just the first one times root 3, first one times root 3, times root 3, times root 3, times root 3. And the hypotenuse was, again, whatever that first leg was, doubled, right? 7 doubles 14, 11 doubles 22, and so on. Get a little trickier to see perhaps when the roots are involved, but it does seem like for this entire table, this opening leg, it got us the second leg, and the hypotenuse in the same consistent way. Again, though, this is a scenario that's being presented to you. I've established all these numbers, and as we learn this last scenario, it'd be nice to just process because we can just look at it and do it. We can just recognize, hey, it's the pattern I saw. I know this has to be just double the 11. We don't have to do any math, any calculations. It's just a matter of recognizing, hey, these fit the bill as far as that scenario. I know what pattern I have to use. I'm going to go ahead and use it. So just like before, the money question is, what is that scenario? Well, let's get at it.